You press keys hundreds of times a day, maybe thousands, and underneath every single key press is a tiny switch you never think about. Here's the wild part. There are at least 8 completely different types of keyboard switches out there right now. Some feel like butter. Some sound like a typewriter throwing a tantrum. And picking the wrong one means you're stuck with a keyboard you quietly resent for the next 3 years. So let's break down every single type. Membrane switches. These came with your first family computer. The ones nobody ever bought on purpose. A membrane keyboard doesn't use individual switches at all. Instead, there are 2 flexible plastic sheets with conductive traces printed on them. Press a key, and the top sheet pushes down to touch the bottom one. Circuit closes. Keystroke registered. It's like pressing a TV remote button, that same mushy, undefined feeling where nothing really clicks. The actuation force sits around 55 to 60 grams. But the real issue is there's no distinct point where the switch actually triggers. You just push down and hope for the best. Most membrane boards cost between $10 and $30. They're light, spill-resistant, and quiet. For basic office work and web browsing, they're honestly fine. The mistake people make is thinking they need to upgrade immediately. If all you do is send emails and browse Reddit, a membrane board handles the job. Just don't expect it to feel good doing it. Linear switches. This is where mechanical keyboards really begin. A linear switch does exactly what the name suggests. You press down, and the resistance is smooth and consistent from top to bottom. No bump, no click, just a straight drop. It's like dragging your finger through warm butter. The most famous example is the Cherry MX Red. It needs about 45 grams of force and actuates at 2 millimeters of travel. That's light, real light. Gamers love linears because nothing interrupts the key press. You tap, it fires. Speed variants like the Cherry MX Speed Silver drop the actuation to just 1.2 millimeters for even faster input. The specs to care about are actuation force, actuation distance, and total travel. Lower numbers mean quicker key presses, but also more accidental ones. Linears are the default for competitive gaming. For typing, they can feel hollow since you never quite know when the switch is activated without bottoming out. The big myth is that linear automatically means better for gaming. It means faster. That's not the same thing. If you're mistyping constantly on linears, they're not helping you win anything. Tactile switches. If linears feel too slippery and you want to actually know when a key fires, these exist for exactly that reason. Tactile switches have a small bump roughly halfway through the key press. You push down, feel a little nudge of resistance, the switch triggers, and you keep going. It's like clicking a ballpoint pen. You know exactly when it happened. The Cherry MX Brown is the classic here. It actuates at around 45 grams with a gentle bump at the 2 millimeter mark. It's the Honda Civic of switches, reliable, everywhere, and somehow nobody's favorite. Tactile switches range from barely their bumps to seriously aggressive ones. Something like the Glorious Panda has a much sharper, more pronounced feedback that typists love. The specs that matter are actuation force and bump intensity. A heavier bump gives clearer feedback, but can slow down rapid key presses in games. Tactiles are the all-rounders. Gaming, typing, office work. They handle everything reasonably well. The common mistake is assuming all tactile switches feel the same. The difference between an MX Brown and a Zelios V2 is like the difference between a frozen pizza and a brick oven margarita. If you tried Browns, hated them, and wrote off the whole category, that's on you. Clicky switches. You've heard these before. Everyone within earshot has heard these. Clicky switches do everything a tactile does, but add an audible click right at the actuation point. It's feedback you can hear and feel at the same time. The Cherry MX Blue is the poster child here. It actuates at about 50 grams with a sharp bump and a distinct snap. Inside, there's a 2-piece stem with a click jacket that physically snaps during the key press to produce that sound. It's like a tiny plastic round of applause every time you type a letter. Some people find this incredibly satisfying. Everyone else in your household finds it incredibly annoying. The The specs to watch are actuation force and noise level. Blues sit around 50 grams. Kale box whites are a bit crisper. Box jades are basically tiny jackhammers strapped to your fingertips. If you want the most feedback possible from a Switch, Clickies are unbeatable. For shared offices and late-night gaming sessions, they're a war crime. The biggest myth is that Clickies are just louder tactiles. They're not. The click jacket changes the entire key press feel. That snap adds a crispness a tactile bump alone can't replicate. It's a genuinely different experience. If you're rocking Clicky switches right now, drop your reason in the comments. I need to understand you people. Optical switches. This is where things get a little techie. Instead of metal contacts touching to register a key press, optical switches use a beam of infrared light. Press the key down, and the stem either blocks or unblocks the light path. A sensor reads the change. That's it. No physical contact at the actuation point means significantly less wear over time. These switches can last over 100 million keystrokes. Traditional mechanical switches top out around 50 to 80 million. Razer and Gateron are the big names in this space. Razer's optical switches come in linear and clicky flavors. Actuation speeds can be incredibly quick. Some fire at just 1.0 millimeters of travel. The spec that matters most here is debounce time. Traditional mechanical switches need a few milliseconds of software delay to prevent double key registrations. Optical switches skip that entirely. The signal is instant. It's like removing the speed bump from your driveway. For competitive gaming, that speed difference is real but small. For everyday typing, you probably won't notice it. The misconception is that optical is universally better than mechanical. It's faster and more durable, yes. But optical switches are locked into specific board ecosystems. You can't just drop any switch into an optical board. Compatibility matters way more than people realize. Hall effect switches. These are the new darlings of the keyboard world. A Hall effect switch puts a magnet inside the stem and a sensor on the circuit board. Press the key and the magnet moves closer to the sensor. The sensor measures the changing magnetic field and knows exactly how far down the key sits. No physical contact, no bounce, no wear point at all. Think of it as a dimmer switch instead of a light switch. The keyboard knows the key's exact position at all times, not just on or off. This unlocks adjustable actuation. You can set keys to fire at 0.1 mm or 3.8 mm or anywhere between. Some boards even let you set 2 actuation points on one key. Press lightly for walk, press harder for sprint. The tech itself isn't new. Hall effect sensors have been in industrial gear for decades. Wooting brought them into mainstream gaming keyboards around 2018. Their 60HE model became massive in competitive circles. The spec to focus on is sensor resolution, how precisely the board can track the key's position. Higher resolution means smoother analog input. The mistake people make is buying a Hall effect board for the hype and never touching the actuation settings. If you set it up and leave everything at default, you basically bought a very expensive linear switch. Topre switches. Now we enter the deep end of the keyboard rabbit hole. Topre is a Japanese company that makes electrostatic capacitive switches. These use a rubber dome sitting over a conical spring. Press down and the spring compresses, changing the capacitance between 2 small circuit boards. That capacitance shift registers the keystroke. It sounds strange on paper. In person, it feels like typing on a cloud that somehow responds. The actuation force is typically 45 grams with a soft, rounded bump. Topre's flagship is the Real Force, a staple in Japanese offices for decades. The HKB, Happy Hacking Keyboard, is the cult favorite among programmers who have opinions about everything. These boards are not cheap. A Real Force runs roughly $200 to $250, and HKB sits in the same range. The key spec is dome weight, 30 grams, 45 grams, or 55 grams, which changes how light or heavy the typing experience feels. Topre is best for long typing sessions. The feel is smooth, quiet, and borderline addictive. For gaming, it works, but it's not the fastest option. The myth is that Topre is just a glorified rubber dome. Yes, there's rubber involved. But calling a Topre switch a rubber dome is like calling a sports car a go-kart, because they both have wheels. Low-profile switches. These are exactly what they sound like, mechanical switches that have been squished down to about half the normal height. Total travel drops from around 4 mm to roughly 2.5 to 3 mm. The keys sit lower, the board sits lower, everything gets thinner. Think of a standard mechanical switch as a sedan and a low profile as a sports car, lower to the ground and quicker to respond. Chery's MX low-profile line, Kale Choc switches, and Gatoron's low-profile offerings are the main players. They come in linear, tactile, and clicky variants, just like full-size switches. Actuation points usually land between 1.0 and 1.5 mm. The specs that matter are total travel distance and keycap compatibility. Low-profile switches use different stems, so you can't just swap on any keycap set from your collection. These are ideal for portable setups and people who prefer a laptop-style feel with actual mechanical feedback. For traditional mechanical fans, the shorter travel can feel like the experience is getting cut off early. The common mistake is thinking low profile means low quality. These are full mechanical switches with the same reliability. They're just shorter. Not everyone wants a keyboard thick enough to double as a doorstop. So there it is. From the mushy membrane boards we all grew up mashing, to Hall-effect switches that know exactly how hard you're pressing. We hit Chery MX legends, clicky switches that announce your presence to the entire building, Topre clouds that cost half a paycheck, and low-profile boards for people who want their desk as minimal as their lifestyle. Every key you press has an entire engineering story hiding underneath it. What switch type are you typing on right now? Drop it in the comments. I'm genuinely curious. If this video helped you understand the difference, hit the like button. It really does help the channel grow. Next up, I'm breaking down every keycap material and profile type. That rabbit hole goes even deeper than this one. Click the video on screen right now.